Okay, so I think it's the time that I think we have like audience already joined. Okay, so let me start on the meeting today. Okay, my name is Boom. Okay, come from Kim Kut Institute of Technology, Lakabang, Bangkok, Thailand. Okay, and it's my pleasure that we will have we will have this event. Okay, Pre-RoboCupIndustrial Logistics League, or RCLL. Okay, today is like to give the information about the league to the new participant. Okay, that will maybe will come and interested in this event. Okay, something like that. And also, okay, and today is on demand. Okay, video. We will record this, and then maybe some participant not join at this time because it's like different from others, right? And this is a video on demand, so that means the participant or you or any team can send these links of the video to others to give information of this league. Today in order not waste the time, I will introduce the speaker today. That right now we have the three speaker to give you information about our league. First is me. My name is Dr. Poom. Come from Kim Kut Institute of Technology, Lakabang. I'm a local organization team. Or LOC. So we'll and today event of the RoboCup 2022 is this year we here on Bangkok, Thailand. The schedule of this is around like 11 to 17 July 2022. So in this year is in set up at Bangkok, and have the big hall in Thailand. So hopefully we can set up and we can start it at Bangkok, Thailand. Because like now the event, the crisis about the COVID-19 situation like there. In order not to waste the time, we have the topic that we will talk about today is introducing about the league. Will handled by Talik Wetman. Talik, can you say hi?
Hello. My name is Talik.
Thank you. And also Christian Depper from Festo. Can you say hi to the audience?
Hello. Good evening, afternoon around the world.
Maybe morning, evening,
or even morning.
All out. Thank you. And also, we have the regulation and Lou and regulation that gives the speed by Talik as well. And at the end, we will have the technical talk that Daniel Savoboda, right? Sorry. Can you say hi to the audience?
Hello, thank you.
Okay, thank you. And also at the end, we have the Q&A to if you have some questions, so you can open the microphone and then talk to us, for the information that you need. So I know that not with the time. Talik, are you ready for?
Sure, I am ready. So let me share my screen.
Okay, thanks.
Should be able to see my screen now, correct?
Yes.
All right. So welcome from my side. My name is Tariq, and I'm part of the technical committee of the league, and that's why I'm here to tell you a bit about what we are actually doing. What you can see here is some picture on a competition of previous years. So doesn't look like soccer or anything similar, because we are actually a logistics league. And let's dive into what we actually want to achieve and what you can gain from joining us. So the RoboCup Logistics League, or in short RCLL, has as goal to replicate the challenges of a modern smart factory logistics production plant. So it's located in the context of Industry 4.0, and the main challenges that you face in smart factories is that typically you have customers that can configure and order products at their wishes. So instead of having a mass production of products, you have highly configurable products for each individual customer. And in order to handle this demand, it's typically a good idea to deploy robots to operate autonomously and manufacture these products with the help of some assembly machines. And this task alone can be complicated, but of course the customer also has wishes and demands, in particular, for example, delivery time windows that you need to respect, and you also need to worry about your own factory resources, like you need to manage your raw material, your machine availability, and so on. And in order to be efficient, one robot typically doesn't suffice, so we are in a multi-agent collaboration scenario where you need to be very effective in order to perform well. And since it's not just the assembly of one single product at such a plant, but rather a continuous production, you also need to focus on having a long-term operation that can run with a high level of robustness so that you can keep producing without stalling too much. And in such a setting, it's typically not really feasible to simply solve the problem optimally once, because you can't really do it. You don't know the orders in advance when the customer will show up, and you need to be highly flexible in order to tackle such a problem. And we as a league decided to replicate these challenges in a game format. So the setting of the RCLL is that you have to operate some static machines that each can do one production step. And each team has 7 machines that they can exclusively use, and then need to assemble those orders that come in over time. And the whole factory setting is constructed to be highly dynamic. So you have pseudo-randomized orders. Your field layout is not always the same from game to game, and also machines may schedule a downtime from time to time, so they may not be available at will. And that's the rough setting that we are working with. And the actual products that we want to assemble are just cylindrical objects with different color combinations as products. We will see in a bit what we actually mean by that and how you can imagine this to play out. And in order to make a setting where people can compete against each other, we have some gamification elements here. So there's a scoring scheme for the assembly of products that rewards you if you build many products and build complex products. You have a 20-minute game window in which you need to perform. And on one field, there are always 2 teams competing with 3 robots each against each other to score the most points. And this all is controlled by a semi-autonomous referee box game controller. So how can you imagine our league to be? This is a picture of 2019 in Australia, in Sydney. This is a playing field. It spans 14 by 8 meters, and this is the playground that you have to work with. Here's also some technical construction of such a map. It's a layout to be symmetrical, mostly, so that it's a fair competition between each team. And now to the task that we have. So as I mentioned, we don't actually assemble some product that we can sell later. Of course, we are a game format in the RoboCup, but instead we build cylindrical objects. Why do we do this? You can imagine this to be like different components that some product can have. For example, a hamburger. You need to start with some base element, like a bun that you always have, and then you can add different things to the bun in order to customize it to your need. For example, you may want to have some salad dressing to that, and that would correspond to some ring color, for example, on a product that you want to assemble in the logistics league. And then someone may want to have meat on the burger, so you put meat on the burger as well, to the customer demand, and maybe some more toppings, and then finally you are done and have your final product. And this is roughly how you can imagine what we want to achieve here. So we have products which are simply cylindrical and color encoded to basically show that these are different configurations for an actual final product that has to be assembled. And how can you achieve such a product? You have these static stations at your disposal that you can use for that, and there are different types of them. The most basic one would be the base station, which simply gives you base elements. And it can provide them in different colors. So the first step would be get a base element from such a station. And then if you want to refine the product further, for example, add some rings to it, you would need a ring station, which can supply 2 different ring colors for each station. And it might be not possible to simply directly mount a ring on an element, but rather you probably need some material in order to actually assemble the ring. And this is modeled by having payments that you need to bring to such a station to a separate slide unit. And this is shown below, where you can see you can need some sort of payment. So what you can do is take another base of the base station, which is used as payment, bring it to the ring station. This base is then consumed. And once you paid, you can bring the base that you actually wanted to bring to the ring station, feed it into the input side of the conveyor it has, and then it refines the product by adding the ring to it, actually. The next station that you have at your disposal is the Capstation, and this has 2 modes, basically. It is there to do the last production step, so it adds the cap to a finished product. But in order to do this, you need to first provide the station with a cap. Similar to the ring station, you first need to provide the material, right? So what you actually do is the ring station has a storage unit next to it, which is called a shelf, and there are cap carriers attached to just waste products which carry caps. And so you feed those into the station in order to let it buffer such a cap. And then once it's buffered, you can use the buffered cap to mount it on the product that you actually want it on. So the first step here would be to buffer the cap to the Capstation, which is depicted in red below. And then you need to take care of the waste product, which you, for example, can use again to pay at ring stations. Then you may need more payments as well, for which you don't need to use the base station. You can also use cap carriers that are still on the storage unit of the cap station. And once you have all your payments aligned, you may want to continue producing your product further. So add more rings to it, maybe add even more rings to it, and finally bring it to the cap station and mount the cap that you just buffered on top of it. And then you are almost done. What you still need to do is to actually deliver the product. There is a separate station for that, which only has basically an input side that you bring your products to. And then you can imagine that there would basically then the delivery would be the delivery to the actual customer that would take place there. So this is the rough production overview that you have in order to assemble a single product. What I didn't show yet is that you also have a storage station at your disposal if you need to store products in the meantime there. And yeah, this is just for a single product, and you already have a lot of steps involved, and you can imagine it gets quite complicated if you have more products that you need to produce, for example, at once. And here I quickly want to stop and want to make space for my colleague Christian Depper, who wants to tell you a bit about his view on the Logistics League.
Thank you, Tarek. So I hope my slides are coming up right now.
Yes, already come up.
Looks good?
Yeah, look good.
Okay, great. Okay, yes, welcome from my side. My name is Christian Depper. I am responsible product manager for robotics and virtual training at Festo Didactic. And actually, my career at Festo started with RoboCup back in 2010 in Singapore, when we first joined, so as a student joining from a university. So I know very well how it feels to work in the RoboCup environment. And ever since then, I am trying to push this league closer to the industrial counterpart, and also give the input on current or actual questions that we face in industry to make factories smarter. As Festo Didactic, we have a very broad range of products that we ship, and this picture here is just to demonstrate what I really love about RoboCup is and our league is that we have so much variance in these systems, but still they all cater to the same problem of optimizing the material flow within factories. And so as Festo, we usually more focus on bigger learning factories such as this. So this is a CP factory. This is our flagship product which we ship to customers around the world. But all these factories are focused on the classic thought of a down the line process with alternatives here and there for the material flow, for example, optional quality control checking, or as you can see here, some milling and turning that is required. But they really focus on just improving the current ideas. And what we like to do with the RoboCupIndustrial and the Logistics League is to really go beyond and focus on how does production aisles work. So focused machines that provide a specific set of skills, how can we combine them together in a way that improves efficiency, that makes it transparent on how to propagate these skills to the outside world. And that is really the strong suit of Logistics League, to take care of the multi-agent systems, of the planning problem, and to work and think in this area of expertise. And that's what we are focusing on with the league. And as Festo, we are on the one hand supplying you with the infrastructure, so all the stations that Tarek told you about as part of the official competition. And also, to get a quicker start, it is possible to have sort of mock-up stations and things like that. And of course, we also provide you with our knowledge and experience surrounding our learning product, the Robotino. So much from our side. I really like the process that we are in and the exchange we're having, and I'm looking forward to welcome even more teams in Thailand. Thank you.
Thank you, Christian. So I will take over again and continue sharing my screen. So maybe a bit of history on the RCLL, since we now hear about the take of Festo. Actually, Festo is the reason why we are here, basically, because in 2009 they started organizing a mini hockey demonstration competition to test out the waters of RoboCup, and they deemed it was too close to soccer, since hockey and soccer are kind of similar on a high level, and it also doesn't really fit any industrial application. So that idea was discarded, and instead they transformed the hockey problem into a logistic task problem. And you can see in the top right, the picture would be something that they came up with in 2010 and 2011, which was the idea to use the hockey setup, but actually simulate how it would be to produce something. And then for a few years, there were competitions using that setup. But quickly it was discovered that the main problem here is that it's really hard to imagine the connection to a real production plant if you just have hockey pucks that are put into different marked areas on the floor. And so Festo thought, okay, let's improve this. And the league as a whole agreed to move to a more complex setup, which involved these Festo modular production systems that we are using up to today. And that's really where we came from. And what can you expect when you are working in the league? So first of all, when it comes to the robots themselves, we use the Festo Robotino as a common platform, which is very comfortable for us, because then we have a fair baseline, as all the moving constraints across the teams are very equal. However, starting from this year, we will also allow similar platforms to be acceptable in a limited scope, as I will tell you about later on. And starting off with this Robotino platform that you can see on the top right, you are pretty free to actually extend it to your needs. So you can add additional sensors that allow you to realize the ideas that you have for the league. And you can also design your own actuator system to actually grip the products that you need. And actually the solutions that the different teams come up with are very creative and also very unique for each team, I would say. You can see at the bottom the schematics of 3 different teams, which all use basically completely different ideas in order to overcome the problem of precise gripping. And we will hear a bit more about that later as well. And so if you have a robotic platform at hand, that's great. But now you may ask yourself, what can I actually do in the league, and where to start and where to end? And we provide you with a small road to success, which basically should outline the steps that you can go through the leap. So of course, the first thing is you need the hardware. So you need some Robotinos or similar things that allow you to move around. You need to extend it to your needs. Add an actuator, act sensors, so that you can actually start performing. And yeah, hardware, of course, is not really enough. You typically need to control this hardware as well. You need to learn how to navigate in the world. You need to coordinate the navigation. Eventually, you need to avoid obstacles as other robots of other teams may be on the field. And once you have this, you also should probably think about how can we actually reach the machines that are standing around. So you need to detect the machines properly. You need to align consistently in front of them with a decent precision so you can actually interact with the machine. And then if you stand in front of a machine, that's still not enough. You probably would also like to interact with it really by having your gripper system be able to take products from machines and bring them to machines. And this is typically within very tight margins. So you need to be quite precise when you provide such a system. And then you think you are good. No, of course you are not good yet, because you still need some high-level reasoning to actually overcome the actual task, right? So the whole planning logistics involved here, the whole dynamic setup that you need to conquer. And there, one basic step would be to first learn how to interact with the referee box system, which supervises the whole game and also is the gateway to interact with machines. Then once you know how you instruct machines and get information from the ref box, you could build your own production strategy for all the dynamically arriving orders in some form. And if you want to actually realize your strategy, you need to enable your robots to actually cooperate with each other and collaborate to work on the products. You eventually might think about working on multiple orders simultaneously. And then, of course, we're in robotics. Many things go wrong and not as planned as if you just looking from a theoretical point of view on it. So you should also ensure some sort of resilience against execution failures eventually. So I think what you can take away from this is there are many different areas that need attention eventually, and there's a lot of things you can do in order to improve your system, which is, in my opinion, very rewarding and opens also your own horizon. If you are, for example, more located in the computer science side of things, then you are pretty much also learning a lot about very much other areas like engineering problems that you stumble upon and so on and so forth. So that's basically what you can expect as tasks and challenges that you can overcome here. I have a small video prepared that maybe even works. Yes, this is from an old RoboCup where we attached a camera on one of our robots, and you can see it in action, basically how it interacts with the machine. And you can already see the conveyor belt here is rather small, especially if you compare it to the size of such a workpiece. It's really a precise thing to land the workpiece where it needs to be, so it doesn't fall off or can't be consumed by the machine. And yeah, this small clip is essentially from a final of 2017. So it was a very tense situation here, where of course both teams wanted to perform to their limits. And I would say, judging by how past RoboCups are, this was probably a very fun and exhausting experience. I wasn't personally there yet in 2017 as I joined 2018. But yeah, this is a rough idea how it looks like. You have robots driving around while other robots very much concentrate on bringing products to machines. And with that, I'm done with my first talk. And for completeness, I listed some resources that you should check out if you're interested. For example, our website, where some general information can be found if you want to stay updated. We also have a RoboCup mailing list for our league that you can join. If you have any more technical or organizational questions, we have committees that handle these and can be reached via mailing lists as well. And if you want to check out on the referee box or the rule book, we supply that on GitHub on our organization. You can check that out. And this is it for the first talk. Thank you.
Okay, and then we have to move to Daniel, right?
No, then I have also the. I can start with the second talk if you like, which would be the rules and regulations of the league.
Ah, yes. Okay.
Is my screen still shared?
Yes, already.
Okay. Then let me restart my viewer because for some reason it actually doesn't like full screen mode sometimes. Now I have it. So while the last talk was more about the general things and how our league looks from the outside and what you can expect if you want to start working in the league, we were also requested to supply you with an overview over the rules and regulation within the league. Of course, what I will tell you here is very much non-exhaustive because the rule book is like 40 pages long and I can't cover every detail. So I choose the basic aspects that you probably need to know in order to get a better idea of how a RoboCup would look like in this talk. So first, generally, we follow a league philosophy where we act cooperatively and fair. We don't really see it as a competition where we need to fight our enemies, but rather where we collectively try to advance the league forward and share our ideas and work together on improving and pushing further the limits that robotics have in the smart logistics setting. We also follow a gentleman's agreement that one should treat others as one would like others to treat oneself, which I guess fits perfectly into that spirit. And in the same way, if there are any gaps and irregularities in the rulebook, we expect that those are brought to attention instead of being abused, because of course you can't cover any corner case of some clever human that might think of sneaky ways of breaking the game, and that's usually how we operate. So I would say we are a very open community with a very nice spirit to work in. And when it comes to the actual game, I think it should also be noted that we also expect that the robots actually leave the opposing robots pretty much alone as much as possible. So in particular, it shouldn't be a thing to actually block the path of the robot actively or ram them or eavesdrop or jam the communication between robots. Stuff like this is not what we actually want to foster in the league. We want to actually advance with the actual progress. By getting better and not by making the enemy team worse, basically. And of course, if you break these rules, then there are, of course, penalties, and in the worst case, you get disqualified, but I think that goes by itself. That should be pretty much obvious. And when it comes to the rule development, what we actually do is we roughly follow a tic-tac rhythm of minor and major changes, so we can bring new ideas to the league, and then in the following year we test how the league reacts to that and how it changes the game, and then we take time to evaluate, and then we do the next big step. And the rule development is carried on by the technical committee. So we are responsible for the rules and the rule book itself. And we typically finalize the rule book of a year around March. So again, this year, in the middle of March, you can expect where RoboCupIndustrial will is for competition. And as when it comes to the objective, follow that are to us also by our industry contacts. And by doing that, naturally, the game gets more and more complex, but at the same time, we need to balance this, and we also do not want to raise the initial requirements that you need to actually participate in the league. So the baseline should be pretty much achievable and remain achievable with the same effort across the years. However, the peak performance may require to actually tackle more complex problems. That's how we usually operate. And to say a bit more about the league itself, we are a rather small league compared to other leagues maybe. And this is, I would say, mainly due to one big factor, that we are difficult by design. So our task that we tackle is a complex industrial context, basically, and it's highly non-self-explanatory. So if you are a viewer at a RoboCup and you stop by, I wouldn't expect anyone to actually understand what's going on by just looking at it. That's vastly different when we compare to soccer, where everyone at least has a rough understanding what's going to happen in soccer, and you stand next to it and can enjoy it and appreciate what is happening, which is a bit more complicated in our league, of course. Also, since we have like this open platform concept where you can work on your hardware yourself and you are not restricted to what is given to you, that of course adds more complexity to the initial workload that you have to do. This should also not be neglected that, it's robotics. Robotics is quite expensive, but it's not only expensive, but in our case also space consuming. If you have a field that's like 8 times 40 meters, that's the space that you need to have at first, right? And typically in local labs, that's not the kind of dimension that you have available in most universities, at least. And that's also something you need to keep in mind. But we will address that later. And the last thing, which is also very fundamental, is basically everything needs to work already so that you can see a progress when it comes to the game, right? So it's very hard to produce even the simplest product, because you need to drive, you need to align to machines, you need to detect them, you need to interact with work pieces, and this is something that's basically a high burden that you have to face when you enter the league. And this is something that we of course recognized. And until 2020, it was basically this. We had this full smart logistics scenario as a game format where you are facing all these issues at once, and that caused this very high barrier of entry. And in 2021, we did something new. We added a new tournament track to our league, which is a challenge track, and it should aim for new aspiring teams. And as a side effect, and the main effect that we actually were looking at 2021 itself, is that it's also suitable as an online format, because we choose to set it up as a single player game, essentially. And since you all probably know, 2021 was no real RoboCup at a physical venue, so we needed to be creative in that year. And we decided to stick with that, to actually improve on the challenge track that we designed there. And this is also a baseline for 2022. The idea of the challenge track is that you split the tasks that you face in a game in isolated challenges. And you simplify the whole setup a bit by reducing the field to a much smaller size, 5 by 5 meters, and only require that you have at most 4 machines on the field. And these are then enough to carry out the most important parts of the production in this reduced format. And as part of this step, since we were forced to have an online competition where we had to provide means to the teams to actually compete in their local labs, we also accepted non-functional versions of these assembly machines, because not every team also owns functional assembly machines at their homes, but rather get them only at the RoboCup events when they are supplied by Festo. And so in 2021, we decided, okay, we integrate these mock-up versions as well. So if you have such a constraint that you don't have access to the real machines, it's still possible to play out the game perfectly fine, even if the machine doesn't work, and basically a human can jump in order to perform the assembly for the machine. And as I already spoiled, the challenges are meant to be single player games, which also helps in the online setting where you don't have another team at your disposal to play against. And the competition format then is pretty straightforward. You have a pool of challenges that you can attempt, and each of the challenges gains you point if you solve them correctly. And then we also added some different difficulty grades for each challenge, so that teams of different progression stages could all have fun with it. And in the end, the team with the most points would win the RCLL in 2021. That's how it looked like. I also added a video link for the challenges that our team submitted last year for those that are interested. To give an idea how small the field really is, it's really not much. This would be a 5x5 meter field with 3 machines placed inside of it. So not a lot of space that you need, and typically sufficient for a local lab so that you can actually work with it. And with that, what are the kind of challenges that we provided? There was a navigation challenge with the goal to test whether you can actually move around with the robots on the field properly. So it was basically a task to visit a random set of points on the field, and the difficulty variance ranged from different number of machines that are obstacles in the world. And then we had an isolated grasping challenges where the focus was to show that you can actually interact with machines by placing work pieces on top of them and picking them up again, and do that robustly a number of times, so that you need to at least perform 6 grasping operations and up to 18 grasping operations for the challenge to work. So, and if you mastered these 2 challenges, you were pretty much in a very good state to start competing already, because once you can drive and grasp, there's not much that hinders you to actually attempt playing on the real game, right? And additionally, we added another challenge, since as I will explain in a bit, it's also part of the game usually that you explore the field, because the machines are not known from the beginning on where they will be located. And so we added a challenge for that, which we called the exploration challenge, where you need to find and report the machines to the referee box. And lastly, we actually added the production challenges so that you can actually show that you can assemble products using the machines at your disposal. And this was the idea for 2021. And it worked quite fine. But still, we don't want to let go of the main track, of course. So the track that we had up to that point was the full smart factory scenario, where you need to compete against another team and overcome all the issues at once, which is the real interesting kicker of this league. So we don't want to take steps backwards in our involvement as a league, but we rather push it forward. So we see it as 2 different tracks that you can compete on, depending on how far you are already with your development process. And for the main track, it was a kind of different match format, where so you have compete against another team, and on a real RoboCup, you would have a round robin phase for placement, where you, based on your accumulated points, will get placed in one of 2 brackets. And then in these brackets, there's again a round robin phase of playoffs, and then the top of the top contender of each of the brackets would be then in the final and have to compete for the title. That's basically the idea of these 2 tracks. And for the main track, the game format, as already hinted, it's like a 20-minute game that we usually strive for, and it is subdivided into 2 phases. It's an exploration phase of 3 minutes, where you need to find the machines, and a production phase of 17 minutes to actually produce all the orders, or all the orders that you can, that arrive online during that 70-minute phase. And the field is a big field that we already saw, and basically nothing special about it. One thing that is worth mentioning is we don't have any special floor that you can rely on. We just use whatever is as a floor there on the venue. So it might not be perfectly even, but that is typically something that Robotinos can handle sufficiently well, and so that shouldn't be an issue, but I think it's worth mentioning at least. And then the game format, of course, would be that in this exploration phase, you find the machine, you get awarded points for that, up to 14 points, which is not a lot in the grand scheme of things, but it rewards you for actually attempting the task. And then the main focus is on the production phase, where there are up to 9 orders that you can produce, which are announced throughout the game. And all the orders have like different times of arrival, different delivery period, different complexity regarding the number of rings and the payment that these rings need. And across games, the complexities of the available products are similar, so you are somewhat comparable between games. And the point scale of the products they scale based on the complexity of the products. You get much more points if you assemble products that are much more complex. And that's basically what you can expect there. And one thing that is also happening in such a game is there are 2 events where a machine becomes temporarily unresponsive. And the last thing that is also an addition is that 20 minutes is quite a long time, and failures may happen, and failures may even be critical. And in this case, what you can do is you twice per game you are allowed to actually perform maintenance on your robot to fix some issues that you have. And this is very time limited. You only have 2 minutes to actually fix the issue and restart the robot. If you can't, the robot is out. But this, I think, should give you a rough idea of how the game formats would look like. And that's all I want to say for that. And instead, I want to stop talking about what are the rules for now and instead focus on what will come in 2022. What will come is that we combine the 2 formats. So we need to combine the approach of 2021 of the challenges and the actual game format that we had so far. And the idea for that is that there will be a qualification day on site at the RoboCup where some challenges are played. And if the qualification challenges are solved, then a team is eligible to compete at the main track, and the other teams are then sorted to the challenge track, and then they compete individually and independent of each other in their respective tracks. And I already mentioned it that we do not enforce the Robotino platform entirely in 2022. Instead, we allow to use different platforms when you compete in the challenge track, because then other teams are not affected so much anyways, because it's a single player game. So the actual changes that we will do to the challenge track will also be quite substantial. So the existing challenges will be slightly altered. So far, we had a wide range of difficulties because in 2021, this was the only format. So the best teams approach the challenges as well as the newest teams that need the most training in the isolated task. And then, so we thought we need to cater to both of these ends and had a wide range of difficulties. And this is not really needed if you have 2 tracks where the main track is for the people that are progressed already. And so we actually want to focus on the challenge track instead, really on the teams that just entered the league and that want to work on the basic tasks and do not really provide these difficult challenges, because once you manage to get the easy challenges done, you should be able to compete in the real games already. And in that regard, we are probably also adding a few challenges, and we are working on that at the moment, so we will see how that will turn out. And the challenge format itself will also be improved, because the rules so far were designed for an asynchronous online event, and now if we consider live events, you need like fixed tournament schedules and so on. And this is something that we will also work on. And lastly, the lifted platform restrictions I already mentioned quite enough, I think. That's basically what is happening in 2022 with regards to the challenge track. And lastly, for the main track, there will also be some changes. Namely, we want to combine the exploration and production phase finally. So instead of having 3 minutes and 17 minutes, you will have 20 minutes of a production phase. And after 3 minutes in the production phase, you will get all the information about the machine positions anyway. So if you struggle with exploration, you can still work on the actual production task after 3 minutes. And if you are good at it, you get a small head start on your production chain, basically. And what we also want to do is, you may have seen it already on the pictures, on the machines there are markers attached that tell you which of the machines it is. And this makes it quite easy to detect machines. You simply need to look out for markers. and we eventually want to move away from markers and instead facilitate these approaches that automatically detect the machine based on its appearance. So, for example, applying the latest machine learning techniques to actually classify what you are seeing on your images. And for that, we will add an option to that if teams want to try it, to actually have still markers on the machines, but these markers will not reveal the type or position of the machines. Instead, you will simply need to get this information from your other sensors and detect it based on your vision, basically. And this is optional, so it's not really a thing that hinders you to start in the real game, because you can still choose to use the markers for detection. But if you want, you can do that this way. And then we probably do also some changes to the order schedule within the game, so which orders arrive, when they arrive, but this is something that's too detailed for here. And a general thing is that we want to provide more options to produce complex products and make the task more challenging for the teams that already are very good at production anyways. And that's all I want to say about the rules. I hope you could take away at least something from it. I know it's very overwhelming if you are not familiar with the league, and so I tried my best to at least keep it as simple as possible. So the main takeaways are that we are now exploring the format of having two different competition tracks, one catering to the individual tasks and one catering to the full production logistics scenario. And with that, I'm finally done, and I thank you for your attention, and I'm ready to pass the stage to Daniel Svoboda.
Okay, thank you, Tariq. Okay, for your information for the regulation and rule, and also give the information about the league at the beginning. And next is a technical talk, right? That maybe it's time for the Daniel. Okay, are you ready, Daniel?
Yeah, I hope you can see my screen now.
Yeah, clearly.
Perfect, thank you.
Yeah.
Well, welcome. We talked quite a little bit about all the different bits of the league, about the rules, about the general ideas. But now, since we're all coming from computer science or engineering background, let's talk about the actual technical challenges that are what really gets us motivated and makes us wanting to work on the league. As mentioned before, we are working in a smart factory setting with on-demand orders, and that imposes some technical challenges that are very prominent, and those are the navigation of the robots in the field, machine detection, gripping, and finally, to bring it all together, a robust agent system. And I will go over them in that exact order, because that's also probably an order that you will be likely to face when you're starting work in the league. And so let's start with navigation. Our navigation needs to be able to deal with two kinds of obstacles, dynamic and static obstacles. Since you're in the main track, not the only person or not the only team on the field, you will have to deal with both the robots from the other teams, which are moving obstacles, and you have to also deal with the machines which are placed on the field and which might create narrow passages and other difficult situations to navigate in. And you can rely on pre-computing anything, because whenever we start a new game, a new field layout will be generated. So each time you're presented with a new environment that you have to face. So hard coding anything doesn't work. Another issue is, of course, that your own robots might cross your paths, and that you need to consider that they might, for example, be additional obstacles in tight passages if, for example, they need to access a machine in that position. And finally, of course, the machine interaction is a different task from the navigation itself. So even if you consider all these things in your navigation, you might block yourself whilst performing actions with the machines. How could you solve that? Well, the most common ways to do this is either to do single agent pathfinding or normal pathfinding with all the agents on all the agents. So each agent plans for itself separately, That requires no communication between the agents, which is nice, and it allows you to easily deal with faulty robots. So if one of your robot fails for some reason, the others are still independent and working as intended. But that never gives you an optimal solution because you're not using all the information that you have to create optimal paths for all the robots combined. It also gives you issues with narrow spaces and passages. So, for example, if two robots want to pass through a narrow part of the field from two different sides, they might block each other, and that is, of course, also problematic. And so eventually you will need to add some form of coordination to avoid these scenarios from occurring and to get as good as a performance as possible. And that will eventually lead you to try to get some form of multi-agent pathfinding going. Here you would have common planning for all agents. It does not require any additional coordination because the coordination is part of that. It can be potentially optimal. Of course, getting optimal solutions is computationally intensive, so probably not, but technically it's possible. And it's easier to deal with those resource limitations because you're considering all the different movements of all the robots. But it's usually reliant on network connectivity to be quite stable, which is something that cannot be guaranteed in a RoboCup environment. You have these large halls with many different competitions going on, many different robots. So your Wi-Fi might not be the best or not as good as it is in your local lab. And of course, if a robot misbehaves, that's the lingo that we use in the rulebook. So for example, if it fails or if it crashes or whatever, it might be hard to handle because some approaches in multi-agent pathfinding have the assumption that all robots work perfectly fine. But once you solved navigation, you can actually go towards machine detection so that you know which machines are on the field, where are they positioned, and how to get to them. The main challenges here is that the robots need the machine positions to align, but they're not really accurately placed on the field. So we have this grid where we place the machines and we give them angles, but it's not like we go there with measuring tape and put them there with millimeter accuracy. No, it's just best effort. The people will go on the field and put them there as good as they can, but no guarantees that it's absolutely perfect. And there's the tags on them. We talked about them before. You can see them here, which identify the machines, but they're also not accurately placed. So you cannot really rely on them for alignment. Also, you have multiple sets of the same machines. And if you face the exploration challenge, you need to figure out how to solve these issues because you necessarily don't know which machine belongs to which team, unless, for example, read the tags or communicate with the ref box in some sense. But the common solutions for that would be to either use the tags, as seen here, which are available and relatively easy to read, but not suitable for alignment, or you switch to a more advanced solution, something that we would actually prefer as a league, to use some object detection model like YOLO and Darknet for more accurate positioning and detection. But the machines might be hard to differentiate because they really just differ in the setup that is placed on top, and you might get false positives from your machine learning model because, well, from different angles they might look very similar. And of course you can never get as much training material as you need to cover all the angles and all the different backgrounds that you might have. So you need a rather good model to get good results from that. And machines might change, as you can see here. These are different machines from the ones that you have seen before. That's because they have a different setup on them for the actual actions that go on the machine. And those are the ones that were used for the detection challenge at the RoboCup Asia Pacific. And so these were just machines that were never seen before by the teams. So you also need to be able to adapt these things. But if you manage to detect the machines and navigate on the field, now you need to actually interact with them. So what you need is a gripper, and this gripper needs, and of course also a system for alignment and object detection. So the main challenges when designing a gripper is where and how to grip, how to deal with the alignment, how to deal with the intolerances that you face, how to detect the objects that you want to grip, and of course the physical constraints, because you can't just build any arbitrary size gripper. You have to be within the constraints of the robot size and within the constraints of the rules. And here, as we see in the league, quite a lot of different creative solutions for how to grip. So I want to give you some examples of how this issue has been solved in the past. So here is the gripper that the team Carry Logistics, which I'm a part of, uses. So it has like these 3 bars that are used to grip the cylinder from all sides. Then next we have the gripper from Team Grips, which is just which just grips it from 2 sides, and which has a sensor placed at the top, which is used to scan the environment in order to place it. And you can see it does work. Then the last example is from Team Solidus from Switzerland. They're using a sort of cone and another stick to hold it in place. Yeah, very different solutions for the same task, but all of them work rather well. So yeah, you can get really creative there, especially if you're a mechanical engineering student. I think you can get lots of your ideas in. But building the gripper is only one part of the gripping problem, because the other part is, of course, the object detection, the alignment. And 2 potential solutions for that are ICP, iterative closest point. So you could, for example, take some samples from the conveyor belt and with a 3D camera and use ICP to compare an image generated, a point cloud image generated during the operation, and just use ICP to detect a match, which is slow but works. Or you do something more advanced like visual serving with a CV model, where you train a neural network to detect the workpieces, for example, and then you can actually use with modern neural networks, you can get real-time position feedback, and you can even like integrate it into a feedback loop like in visual serving and position yourself very accurately and smoothly. But that requires, of course, a lot of training data to identify the workpieces. Then finally, once you have all these different technical challenges put together and solved, then you can build your nice agent system, which brings it all together, actually makes your robot a smart and reliable robot. But this also comes with a lot of challenges. For example, you need to solve communication, you need to solve skills, which is the term that we usually use for the low-level interactions. You need to have it reliable and robust, and you need to be able to follow long-term objectives, because producing one product just requires so many steps that you will have to keep track of them, and you will maybe have to adapt based on what your robots do and don't do. And there have been different approaches that we've seen in the league, for example, centralized and decentralized approaches, goal reasoning, scheduling, planning, and so on. So quite a lot of variety, so it doesn't make a lot of sense to go over the examples there. And instead, let's go into the challenges with a little more in a little more detail, and start with communication. Communication is required to coordinate the robots, because if you have 3 robots on the field, you can't just simply not do any communication at all. You need to make sure that they're not blocking each other. You need to make sure that they're working cooperatively, and you need to be able to and you need that, because otherwise you won't be able to make a lot of points in the game. But the problem, as I mentioned before, is unreliable networking situation, so you need to be able to deal with that as well. Then regarding the skills, you need to interface lots of lower level components. You need to interact with the Robotino. You need to interact with the with your gripper system. You need to interact with all the sensors that you put on your robot. So for example, maybe you have some laser line operations going on. You have some 3D cameras. You have some normal cameras to detect the tags. Whatever, many different sensors, and they all need to be integrated with each other to have your robot system going. And also what you need to deal with is reliability and robustness. Robots might fail. You might need to detect that. You might need to deal with that by, for example, having the other robots not rely on all the robots being there, because if one robot fails and it's not recoverable and you have 2 robots left, then you need to deal with that situation as well. Failing machines can be turned off during the game for set amounts of times, and you need to deal with that as well. You need to deal with dynamic environments. The situation is different in every game. You have different fields, you have different orders coming in. The orders are not available at the beginning of the game, so you need to be able to deal with that. Maybe adapt your strategy if something fails, or if a new order comes in that has much more value. And you need to deal with incomplete information, because, as I said, it's not available at the beginning of the game. So you need to adapt be able to adapt your strategy to get as much as you can out of the game. You simply just can't rely on planning just once at the beginning of the game. And finally, you need to follow these long-term objectives, because we have short-term actions like bringing a product from machine A to machine B, but they are just a small part of producing an entire workpiece. So you need to combine these short-term actions, maybe across multiple robots, in order, because if you build the product in the wrong order, then you don't get any points, and you need to follow them thoroughly. You need to deal with issues that might occur. You might lose a workpiece, or you might do some, for example, you might need to fill a capstation to mount a cap, and you need to keep track of all these operations, make sure that they're done in time, and then eventually you might need to scrap all the things that you've done right now, because a more important product comes in and you want to focus on that, and you need to deal with all these things. So yeah, then again, planning at the beginning doesn't work. You don't have the information, you don't have the you don't know what's gonna happen during the game. You need to be reactive, you need to be aware of the situation, and you need to be able to be flexible and evaluate the situation at all times. And those are the challenges from the agent system. And with that, I want to thank you for your attention. We're already over time, but I hope you got a nice insight into the league, and I hope that you will join us in 2022.
Thank you, Daniel. Poom, if I may add some final words. So, of course, it wasn't mentioned specifically, but all of this implies that we have a fully autonomous league, right? So at the beginning of each game, the robots are switched to autonomous mode. So if Daniel talks about you need to be reactive, then it's not possible for a human to be reactive. All of this has to come out of the agents. That's, for me, it's very important. If you compare this, for example, to the Rescue League, where remote sessions are part of the challenge, right? So just to be clear. So at the start of each game, it's completely autonomous. Also, from my personal perspective, what's also not in the slides, my background is economic engineering with a specialty in logistics. So I got hooked into the league because of the material flow problems and creating an agent to solve it. But what really kept me going, and where I really also saw my personal development, was the project management, because this is a league where you really have students coming from multiple disciplines. So this interdisciplinary project management, where you need to understand how a math specialist has to work with a mechatronics specialist, and all of this gives you, in my experience, invaluable experiences for your professional life. And so I highly recommend to invest time and to follow through with this kind of projects. Thank you for your attention.
Okay, thank you for information for Tali, Daniel, and also Christian. Okay, for I think the variable talk today. So I think you move to the last session. The last session is Q&A, questions and answers. I'm not sure that the audience here, do you have any question or not? If yes, okay, you can raise your hands in. You can raise your hand in the chat or in the the applications as well. I'm not sure that. Do you have any questions or not? Okay, one chat that I saw is
I see one hand from James.
one hand from James. Okay. Okay, James, we can ask the question.
Okay. If I have a like a familiar platform, right? Not Robotino. How I need about the specification that I'm not sure it's met with the competition or not. How can we find that information?
Well, as Tarek mentioned, the idea is to give you the possibility to start to work in the challenge track, but we would expect midterm to switch to Robotino platforms because we need to establish a fair baseline for everything.
Oh,
So
okay.
within the challenge track, you need to make sure that your robot is capable to interact with the MPS on the physical level, but other than that, we don't really have specifications.
Okay, sure. And I'm not sure local committees if our team in Thailand or the other have some some more question. Do we have any contact like a post in somewhere that we can contact to if
Okay.
you have any more question?
Okay, sure. Like a contact, right? I'm not sure that
Yeah.
the contact for the technical or any others because like okay in Daniel's slide also have the contact, right? And also Tariq, you still have the contact in the slide as well, right?
Yeah, I have. So I linked the mailing lists for TC, OC, and also for the general mailing list. And so basically, if you have anything that is regarding the rules or some technical things regarding softwares or whatever, that would be the TC side of things. If you have any questions regarding the registration with the RoboCup itself, for example, that would be more the OC or the local chair that could help you out there. And if you don't know where to send your question to, when in doubt, send it to the normal mailing list. We are all subscribed there as well. So if you have a question there, we will find it. So
Of course,
Okay.
if your question is more targeted towards Festo, I see that my colleague is also in the call, and of course, Festo Thailand is available to you.
Oh, it's okay. So you have
Thank you.
Lachapuk, right? That okay come from Festo Thailand. Okay, in the main contact as well in case of the hardware. Okay, part for the Festo part, and also I also have like my contact as well for the local committee. Okay, if you have the questions, okay, this is my email. So that means you can okay text me okay by email, chat me by email if you have any questions. So if I can leave I can send a message to okay the team as well. Okay, this is my contact. And other questions? When you have another questions or not? Okay, before we leave the chat, we have to leave the meeting today. Okay, so if not, okay, maybe it's my question that okay, can we share the slide that we present today to the audience? Talik, Daniel, or Christian?
so I can send you the slides. So if you want to provide them to everyone, I'm fine with that.
Okay, okay, that's gonna be okay. So I think, okay, this time is like okay around 10:15. I think don't have another question. I have one question, right? Oh, okay. Okay, this is the link and also the contact that you can okay text chat the email like that. Okay, before we leave, okay, Christine, Daniel, and Charlie, can we take a photo together? Yeah, at the
Sure.
end. Okay. Okay, are you ready? Start capture now.
Always.
1, 2, 3. Okay. Okay, thank you. I think this is the last session, and also, okay, have to say thank you a lot. Okay, for information that I think is clear for the audience. Okay, that about our league, and also for sure after March, right around March, we will have the new rule book, finalize of the rule book, and maybe we can come again to give the information about that, like clearly the standing, explain anything on that before we have the competitions like there. Okay, So if you have that, okay, we'll track your email as well. Okay, maybe we can join like this time. Okay, thank you a lot for information, and see you in next time. And hopefully you see you and also the audience in Thailand, because in Bangkok and also Thailand have many places that we can go together, and we can like have the competition, and we have like you can travel all around as well. Yeah. Okay. Hope to see you in Thailand. See you. Okay. Bye bye.
Thanks for organizing this, and
Yeah,
see
thanks
you.
for having us. Bye bye.
Bye bye. See you.